In this video, I would like to draw the unit circle, and by the end of this video, I'd like you to come away with the idea, these two key ideas, one being, and they're two that are really related, that the cosine of any angle along your unit circle is just considered to be how far along the x-axis you need to go, and that the sine of any angle can also be considered how high up or down along your y-axis you need to go to get to that coordinate, right? And so what I'll do is I'll just draw the unit circle, and we know that the unit circle has a radius of 1. That's the definition of our unit circle. So let me just go ahead and draw our Cartesian plane over the top. So I'm happy with that. And here's our x-axis, here's our y-axis, and we'll define the radius of the unit circle as being 1. So, oops. Let me just write this down below. Unit circle, radius equals 1 unit. So essentially, anywhere from the center to the edge, right? Doesn't matter where along, as long as you touch the unit circle, the radius is always going to be 1, right? So let's use that idea. If I go ahead and place any coordinate on our unit circle, we can actually use this idea that our unit circle is 1 to make these key ideas, right? That the cosine of any angle is just the x-axis, right? How long along the x-axis you've gone. So let's do that. I'm going to go ahead and just finish off by drawing a triangle to show you that when we draw a triangle, all we're really doing is just identifying that this coordinate right here is just how far along the x-axis you've gone and how high up along the y-axis you are. And that we can use to define the position of this coordinate, right? We can define it by how far along the circle we've traveled, but we can also define it as how far across this x-axis and how high up. And at this stage, we don't really know the length of this line here. So we're going to give it a variable, and seeing as we're on the x-axis, we'll call it x. Okay, that can be x, and to assign a variable to how far up we are, we'll call it y, seeing as it makes sense with the y-axis. And we're going to try and define this angle here, and we'll call it theta. All right. And so what we want to come and try and do is we want to use our existing knowledge of the trigonometric functions of a triangle. And if we just write them up the top left, we know the acronym SOHCAHTOA. We know that's a famous acronym for the sine, the cosine, and the tangent of angles in a triangle. And we're going to use those ratios to eventually create these two key ideas. All right. So looking at our angle here, if we have this unknown angle, right, we're going to assume we don't know what it is, and that's okay for now. But if we wanted to know the cosine of this angle, well, the cosine is just a ratio between, or if we go up to our little acronym here, the cosine of an angle is just a ratio between the adjacent side and the hypotenuse of a right angle triangle. And considering we have a right angle triangle here in front of us, we can use it. So from here, the cosine of this angle is equal to the adjacent side, so x, whatever this length is, divided by the hypotenuse, which we know, because it's a unit circle, we know this side is always going to be 1, the hypotenuse, because it's the unit circle. And therefore, adjacent over hypotenuse, in this case, is x divided by 1, and anything divided by 1 is just that thing. So we know, and we'll write it on the right side, the cosine of our angle here, which we'll define as theta, is just x. And that there is our key idea. That's our first key idea. So the cosine of this angle is just essentially how far along our x-axis we are. All right. So I could actually rename this x. I could rename it as what we just defined it, as the cosine of that angle. Now, this really only works when you have a unit circle, right? If this unit circle was not a unit circle and it was any other number, it wouldn't work. So that's what the reason why it works on a unit circle, because we can divide by 1, right? So along our x-axis, we can define it now as the cosine of theta, and it also works for the y, right? And let's uncover why. Because when we go ahead and try and find the sine of this angle, right? The sine, well, the sine of an angle is just the ratio between the opposite side and the hypotenuse, right? So the opposite side of theta is y, and again, the hypotenuse is 1. So y divided by 1 is just y, right? So we can then draw upon, we can write our last key idea that the sine of this angle is just y, okay? How high up or down along the y-axis you are. So again, if I zoom in here, I can rewrite y as the sine of that angle. And so as you can see, just to finish off, we have any angle along our unit circle, right? We can then see how far along we are along our x-axis, and we can explain that as being the cosine of that angle, and how high up as being the sine of that original angle. And that basically just allows us to write some coordinates here for this point right here, and that is, our coordinates are the cosine of the original angle, and the y coordinate is just the sine of the original angle.